Hi and welcome. This week I've invited Bill Finnegan back to the workshop to show us how to shim a 5-speed gearbox for a big block Moto Guzzi. I'll let Bill take it from here.
Well, good morning everybody. Well, I hope it's morning for some people. Today I thought we might talk about the rebuilding of the gearboxes for the 5-speed Tonti frame model bikes. This discussion's come up several times with Mike and Mike's Machines because the number of issues that I come across having to repair these things by people incorrectly adjusting the gearboxes. These are one of the few gearboxes within the Guzzi range that really have to have a lot of adjustments done. There are 3 critical adjustments and you need reasonably good micrometers or verniers to do it, and you need spare parts to do it with. If you don't do it, the box tends to fail fairly quickly with catastrophic failures of bearings and gears and things like that. So I thought we would have a bit of a run through of the way I was taught to do it many years ago at the factory. There is other versions of doing it. I've seen the way the Germans do it, and I'm not quite sure where those adjustments and procedures came from. Maybe it's something they did and worked out for themselves, but I still do it the way I was taught some 40 odd years ago. Whether that's right or wrong, it seems to be successful in every gearbox I do in here. So we'll start off by looking at a gearbox that I've got here today and some perhaps unrelated to the adjustments, just other little tips about the gearboxes when you pull one apart and how to identify maybe some critical issues. One of the things with this gearbox is when you look at the gearbox transmission numbers on them, you can actually tell a lot about the gearbox, maybe what should be in and shouldn't be in. And this happens to be what we call a close ratio gearbox. And we know that by looking at the engine number, and this has actually got ZD stamped on it from the factory. ZD stood for a factory installed close ratio gearbox back in the Le Mans 850 days. So you could buy special order. When the bikes were ordered by the importers, they would place an order and they were built on the production line with these close ratio boxes. Very rare gearboxes now, impossible to buy the gears for. If you're lucky enough to have one, you need to look after it with a great deal of care, because trying to get any spare parts for it is just about impossible. If you break gears, you'll probably have to have them made, and that can be quite expensive. Or in this case here, a lot of these gearboxes you will see ZD stamped on a case. When you open them up, they've got helical gears in, so somebody's robbed them. So it's a bit sad if you think you've got a factory-built close ratio gearbox, but this happens to be one for this customer. So first of all, I'll just probably, before we talk about adjustments, just run through a couple of things that I've been aware of and learnt over the years. When you come to put bearings in and out of these gearboxes, the factory is recommended that you use their factory pullers to pull them in and out. And that's fine. I don't have a major problem, but I don't like pulling cold bearings on aluminium cases. They tend to drag and pull out bits of metal. So I normally heat the cases, both front and rear cases, when I'm trying to get bearings out. So first off, you obviously need to remove the locking plates on the 2 main input bearings. So there's one down inside here and another one here. Then you just turn the cases over, well I do, on 2 bits of wood, and we use a barbecue gas or propane with a blowtorch on it, and you heat these cases to about 110 degrees. I mean, if you've worked in automotive most of your life, we sometimes have terms that perhaps are a bit alien to people, and you hear people say, oh well, when it spits back at you, it's hot enough. So how hot is when something spits back at you? And that can be a bit of a challenge if you sort of trying to pick it up from day one. So the temperature's around between 110 to maximum 120, no more. And the bearings will normally, in 99% of the cases, as you're heating, you'll just hear them drop out. If they don't, if you pick them up with not with your bare fingers, but with gloves on, and just give them a bang on the bench or on bits of wood like that, the bearings will drop out. Let the case cool, then you can clean them up. Now, when you come to put bearings back in these things, you need to be aware of that it's supposed to be Loctited by the factory, It's a green Loctite, not a red one, so it's a medium strength and not too much. Again, I heat the cases to around about the same temperature, so 110, absolute maximum would be 120, but about 110 is, I'll stick pretty close to it. A little bit of Loctite on the bearings, just smeared on, and we just, once you get good at doing this, I mean obviously if you've never done this before, you can get the bearings slightly cockeyed and they won't drop in, so you will need tools or a punch to actually quickly straighten it up and get them to drop in, otherwise the case will shrink and lock on the bearings and you won't get it out. But the critical thing to remember, when you Loctite bearings on these cases, there's oil feeds down the sides of this bearing. There's some oil feed on this one and the same in this case. If you put a lot of Loctite in, which is fairly common that I see, they Loctite them in place, all those oil feeds to the back of the bearing are blocked. Now no oil can go in behind the bearing. It has to come through the gearbox shaft from the front, which tends to have the view of probably limiting the life of the bearing long term. The other thing I'd like to draw people's attention to is most people will just go to a bearing service place and buy bearings. Now these two big bearings that hold the, I refer to the input and output shaft, Guzzi give them a different name, they call them a secondary, and I forgot what the other one is now. This bearing has the same number on it, but the difference between them is one is called a maximum load bearing and one is called just a standard bearing. In other words, there's a different number of roller bearings in. This same part number for both these bearings. This bearing has 18 balls in it, this one has 28. If you use these bearings, they will fail in about 10,000 K because of the actual load along the shaft. They have to take a lot of weight this way. So I do not recommend using these, although most people do use them. And talking to a couple of bearing supply places that I deal with, they will probably supply you this bearing as opposed to this one, unless you ask for it, because they're exactly the same part number except for a code that goes right at the end and it tells the person a little bit more about it. They just look at it and go, yeah, it's a 601 or whatever the number you're looking for. So be aware of that. My advice is do not under any circumstances use this bearing. Problem being is it's a lot more expensive. You can buy bearings like this depending on what country they originate from and everything else, but I've seen these down as low as here in Australia, $28 for this bearing, $90 odd for this one. That's a NTN type bearing. This one is NSK, I think it is, still a good one from a general manufacturer, but less rollers in it, ball bearings in it. So please be careful of that. The other thing to talk about is a little bit is when we put the input shaft into the gearbox, there's a couple of O-rings that need to be inserted in. So these seal and it stops the oil feeding down through the splines and coming out through and into your clutch everywhere. So always replace these. However, if we look closely at these clutch hubs, and they're all made this way, and I don't know whether you can see this or not, but it's been ground off inside, but you can still see parts of the root of the teeth still left there. Oil can still pass through there, even with the O-ring seals on the back here. So there's one O-ring that goes there, like that, to seal on the outside, but also there's another one that sits down inside. So oil goes through there. I have approach where I use Japanese, which is a Honda product, 3-bond, and I actually smear a little bit of 3-bond evenly around on that area when I'm assembling it. So when you push them on the shaft like so, we get a little bit of 3-bond sealing down here like that. So that goes on there, sits about there, so make sure that it actually is oil tight, stops any oil coming through. Also with seals, you should never ever use normal grease on a seal when you're assembling it. Should be like a silicon based product, because what happens with seals is, with normal grease on a high speed situation, this is running at crankshaft speed, when you start it up, is they will burn, the seal will actually burn on the tip of the surface. So then the seal will start to leak a little bit straight off. So use a silicone based grease, and you should never ever have an issue with them. The other thing is then when we get to putting this guy on, so I'll just flick that out of the road. So this sits on here, and this special nut, which is a pain in the backside as they call it, to try and do up. Most people Loctite this, and it is okay to Loctite it, but be careful how much you put on, because it makes it impossible to get off. This gearbox has been pulled apart before I got to it, which surprised me, and the only way we could get it apart was this had been Loctited, but they obviously had not the right tools to do it. So as you can see, there's the cold chisel marks to do it up, and it was heavily Loctited. I could not get it undone with the factory tools. So the original tool looks like that. Physically could not undo it, just not possible. So we had to drill it using a cold chisel, split it sideways to get it opened, and it took nearly an hour to get this off the gearbox. So that adds up to a lot of time and money for the customers to pay if they're not careful. So be careful when you do it with a Loctite. That's about it from a tips point of view on bearings and things like that. So what we might now do is we'll go into discussion on the 3 critical adjustments for measurement is required. So the 3 measurements that we have to do is, and they're in service manuals, but a little bit hard to understand, is, as I call it, this is the secondary shaft or output shaft. This guy here, there is no adjustment on. We've got the cluster, in English terminology, cluster gear. There's an overall measurement of that, quite critical. And the third one is the selector drum. Now the selector drum is the one that seems to be catching people out over the years. I've seen it's not done correctly. And there is some tips that I was taught at the factory that probably nobody else has ever heard of. So I'll talk about those when we come to do them and how to do them. So what we'll do is we'll start off first off with, we'll move a couple of these out of the road. This guy here. So we have a needle roller bearing that goes on the end. So we'll get that off out of the road. So there is a measurement from this bearing to this surface here. So with that we need to use your vernier. So I'll just sort of step back and grab one. Now verniers, we'll talk about those a little bit. There's lots of verniers on the market. You can buy them for probably $20 or even slightly less here in Australia. I don't know about overseas places. I tend to use fairly high quality tools, and maybe this is not everybody's choice because they're certainly a lot more expensive. This one's about $220 odd. Most people won't spend that sort of money, but we do need them to be accurate because we have to chase 0.0405 of clearance, and it is that critical on some of these adjustments to get it right. So we'll turn this guy on, check for 0, open and close a couple of times, make sure the jaws are clean, so just should a bit of a clean cloth. Out again, so 0, 2 or 3 checks, okay, 0. So this measurement here, we need to measure down. So you have your 3-piece bearing. Again, check the condition of them. If they're slightly worn, always replace these guys under a heavy load. And this is the adjustment shim, and there's 3, I think 3 from memory, different size shims. So I'll just put the original one on for the moment and see what the measurement comes up as. And that measurement should be, so take your time when doing this, just get your caliper very close. So this should be 167.09, and according to the spec they give for it, which I can never remember I should remember off the top of my head some of these clearances, but I don't. It should be, I think from memory, 167. I've made some notes here. So if we look at the spec in the workshop manual, it says 167.1 to 167.2, and I had 167.09. So that means that that is smack in the middle of the range where it should be. So that means that the original shim that went with this, plus a new bearing. So quite often these will be worn, and just by replacing the bearings we'll bring them back up the spec. So we know that clearance is now correct. So you can pack that up, put that aside if all the gears, there is another needle roller this end of it, but unless the bearings are badly worn you wouldn't replace that one. The only other thing I should mention, going back a little bit, is where this cluster fits into the back case here, this should be a reasonably snug fit in there, so a little bit of an interference fit. Sometimes you find they're not, they're undersized on the shafts, or they've been spinning for some reason, so you may need to slightly. The disadvantage with Loctiting is this has got to be able to move when it first goes in. It's got to move back and sit in place, so I sometimes will put a small pin punch mark just to tighten these up in 4 even spots. This one is a little bit loose, so I've already put 4 little pin just to tighten a little bit so it actually wants to hold. They're not supposed to be that interference fit like you would on some other transmissions, but it's got to be nice and tight in there. So we know that one's right, so we can put that one aside. I guess the other thing to remember is the correct order of putting these together. Pull boxes apart and you suddenly find these things are all over the place. So there is a correct way to put them together. I've actually seen them with these part of the ground shim washers in the wrong order, and they'll have a spacer sitting in the middle of it, so they've got a spacer with a bearing running on it. Sometimes I've seen them with all the bearings together, so they'll just run the bearing straight down on the gear. They'll have these sitting this way and a spacer on that way. So do pay attention when you come to assembly the correct way of doing it, which should be the bearing in the right order. Like so. Now we'll move on to what I refer to as the output shaft. This one's a little bit fiddly to do because we've got to measure from this surface. I don't know whether you guys can see this clearly, but we've got to measure from this surface here up to the front of it under this bearing here. So to do that you need to take this off. Now the thing to remember with this nut, it's a left-hand thread, so when you come to take it off it is a left-hand thread. So we'll just spin this off, lift the bearing off. What we need to do is measure from the very front of here, so where the shims are, to where the back of this gear goes on here, but there's also a little O-ring here that does some sealing. So when I press against that, you've got to be sure that that gear is actually touching metal, and because normally there's a nut doing it up tight. So the better way to do it is remove that O-ring. So we'll just flick that O-ring off out of the road. Pop the gear back on, and the clearance we're looking for will be, what was I say, 144.7 to 145.2. So again, making sure we're on 0. So measuring from here to here. So you've got to make sure it's squeezed together. So this will now, hang on, I'll just, I should turn this around so you guys can probably see this a little bit easier, if we can get it to work that way. Not so easy for me to work back to front. So according to this, I'm measuring 144.97 to 145. And the spec was 144.7 to 145. So that is within the range that we should be looking for. Critical distance, because that sets the depth of the bearings up, this guy, where it sits in the front of the gearbox. There's not a lot of clearance between when this nut is on and done up on here. There's not a lot of clearance between there and down inside the housing of the gearbox where that sits. Because if it sits too far forward, it actually will bore a hole through the front of your gearbox. So again, quite a critical clearance. If it's incorrect, you've got one big spacer, which is the one that sets up for the bearing. That's the normal shim that controls the bearing, and these are the adjustment shims, and these are all at constant size all the way through. So you just select 1, 2, 3, 4, and these are 0.5 each shim. So you need to select how many it takes to get that clearance right. Again, be a little bit fussy with it. I've seen plenty of these gearboxes fall apart and they just use normal washers. I've even seen one with an aluminium washer shoved in here. I'm not quite sure how long that would have lasted, but certainly the gearbox is not going to last very long. Okay, so if you know it's right, then the bearing can go on. Left hand nut. A little bit of Loctite, green, not much, and then you need to do it up to the correct torque. Now, you need to be a little bit careful how you hold them. Most people, if you're doing your own gearbox at home and you feel confident, you think you know what you're doing, is fine, but having the right tools is a bit of a problem. This is a copy of original, similar to a factory tool. It's made out of a universal joint and just a piece of flat steel. Fits on there. So those gears can fall off. All you need to do is put it up into your vise, like so. That way we don't chip any of the bearings. And then we need to do this up to a torque of, it's in foot-pounds, it's 38, maybe 40 foot-pounds of torque. Not overly tight, but certainly tight enough. So put it in there, socket on top, do it up to the correct torque, and then remember with a pin punch to just fold that little tang down in there so the nut won't come off, and you should never have a problem. Okay, that fixes that one. The selector drum is the most critical one. It sets the position of the selector forks, and I'll shift my hand out of the road. So in neutral, we've got to make sure that these selector hubs are dead in the middle. Otherwise, when you come to change gears, it binds up one end or it doesn't engage properly the other end, so the gears will either jump out or you have difficulty in and out of gear. Now, the factory have pre-machined the cases to known depths. Now, one of the issues that I have found over the years is when these tend to wear a little bit through lack of oil or dirt and everything else in, if we look at This is an aluminium, alloy on that end and steel on this end. That's hardened. Some of these are alloy and some of these are steel. They do wear in this surface. I've actually seen people machine this to get a flat surface. So now this measurement from here to here is no longer a factory spec. So trying to set this up so it works right is a bit of a problem. From the factory, this is supposed to be 153.9 plus or minus 0.5 is the approximate measurements you would expect to see one brand new. The other thing is when the shims come out, we have a big diameter one. That is to stop these rollers, which were where the selector drum picks up and turns this around. That's to stop these from coming out. So that will sit there. And we will need minimum 2 adjusting shims or more. It depends on what the clearance we finish up with. When you pull them out from a factory built gearbox, you could have 3 of these ones. There'll always be one of these, or there should be, because otherwise there's nothing to stop. So that when that sits like so, as you can see, it's blocking the rollers from coming out. If you don't put that in, and I have seen these assembled minus this, and maybe 8 or 10,000 k later the gearbox jams up or one drops out completely, it gets in position and then they've got no gear, so you've got to strip the gearbox and find out why you've got no gears or can't get it out of a gear. So that's definitely got to go there, that's the first one. But the shim that's down the bottom here, when you pull one of these apart from the factory, will be the biggest shim. The ones that go this end will be smaller. And what I mean by the biggest, it will always be approximately 1 millimetre. Should be no smaller than approximately 0.95. So if you've got one that's got a 0.65 or 0.75 shim in, it's most likely been pulled apart and somebody didn't know this theory. I never knew about it until I was taught about it. This shim will be the biggest one. So when you measure them, you'll go along and measure them, and it should be close to 1 mil. In actual fact, this one is 1.1 millimetre, but I said 0.95. So if you've got anything much under a millimetre, you need to be a bit suspicious that it's been definitely pulled apart by somebody who really didn't understand what it is. So that is the first shim that goes in there, is that 1 mil shim. Always. That end, and then we have to work out the clearances. Now, working out the clearances from here onward is a little bit complicated, and you do need quite good measuring equipment. We've physically got to measure the distance from this surface here down to where the selector drum fits, which is that pad there. We then got to turn that measurement around, and we've got to measure from this surface down to, well, I'll start this surface here, down to where the selector drum sits there. Add those two together, then work out the thickness of a gasket and decide exactly what the clearance is we've got so that we can put the right shims in up this end. So we know that this one will be a 1 mil or 0.95, that's a given, and all the adjustment ones up there. So you could have 2 shims up here, we could have 3. I've seen up to 5 shims up here, which means that this has been something's been machined. It shouldn't be that many. Normally there's only 2, maximum 3 on perhaps a worn gearbox. So if you've got that much clearance, there's a problem trying to figure out what it is that's been machined. So that's why I gave you that dimension before, 153.9 plus 0.05 minus 0.02. So that's a known distance from the factory on a brand new one. So if it's well under that, then you've got to compensate that for start off. So that shim would need to go up maybe 1.2, even 1.5. It just depends. So when they do that, it's a consuming job to figure out what it is. So you've got to put shims in, decide which one's got to be in, and then work your clearance out, because trying to get this adjusted is impossible. I know, as I mentioned before, the Germans cut the cases a bit out of the case so you can actually see and measure in from the side through here. That's a problem because each one of these cases are slightly machine different. So if you've got a case that you're using as your measuring device, it's probably going to be different to the one you're putting in it. So the clearances you work out may not even be right. It could still be wrong. So I don't believe that is the correct way to do it. I still think this is the way to do it, and I have certainly a few people every so often ring me up from time to time, including people who work in Guzzi shops here in Australia. I've said, I've got a gearbox, I can't fix this problem, it's really difficult getting out of gear. When I ask the question, how did you measure? None of them do this method. So, and this is not really publicised, and Guzzi never, it's in the workshop manuals roughly how to do it, but you do need to know some probably design information of what, and this is shim here, this 0.95 to 1 mil is the critical one on that one. So what we'll need to do now is start to measure these cases and try and work out what's the distance between that point there and that one there, so that we then can do the adjustment on this with the shims and then work on our gasket, and we'll discuss the gasket in a minute. So we'll stop and I'll come back to you when I get organised to do this measurement. Right, back with you guys. So as we were talking before, we need to now measure where that selector drum goes, that's as many point. We've got to measure from there, about like that. We need to measure from that surface there to that surface there. So being together, we've got to measure from there to there. But obviously if this is all bolted together or we can't get to it, it's pretty hard to measure. So what we've got to do is use this surface here as our reference point and calculate back. So it does require some maths and it does require some measurements. So what we need to, so that we can be a little more accurate, I tend to measure in 3 positions. So what we're going to do, we're going to measure in 3 positions. So by putting the vernier in a couple of different positions, and then we're going to average the reading out. So it takes out any possible imperfections in the case and everything else, and it's a more accurate way of measuring. So with a depth gauge, now this is not a digital one or a dial type gauge, it's a emitter 201, so they are quite accurate. Some people are not very happy about measuring with these ones because we've got to calculate the tenths and the hundredths as we work our way along, and I much prefer to use a digital one. I'm okay if you've got a digital, but if you're going to buy a digital gauge, it's going to be expensive. A manual, I've had this many years and I'm still very happy. So sitting on the case, I hold it. Maybe this should be wider. Some people suggest you should put a flat bar across here. I'm okay with that. But then you've got to be very careful when you measure that you subtract and you've got no dirt on it and things like that. So I am okay with this method. So what we'll do is we'll go down and we need to measure in those 3 positions. Carefully bring it down. So it's a little bit long, slow-winded, and again we've now got to decide what that measurement is. So this will be 13.8. I make that one, so we need to record this 3 times. So one. 138. So case is nice and square, so that's a good sign. So in 3 positions, 138. It could have been a slight variation of 0.00 but I don't think that's really going to make any difference. So that can be put aside now for that one. So now we need to figure out what it is from, again, this surface down to that same position where the selector drum fits in on this one, which is there. Again, 3 positions is probably better. So usually it's a bit easier to, because that's wobbles on the bench. If you put so this is 19. 19.1, 19. So again, 3 positions, to just take an average of it to make sure that a little bit tricky to this, so you just need to be a little bit slow with it. So again, 19.1. So we need to add those together, but we now also need to consider the gasket, because we've got a gasket that sits in between the back case. Now, standard measurement for a gasket is 0.2 if I remember rightly. Brand new gaskets. They should be these thin paper ones, not big thick ones. $19 or $20 should be the, so the standard I just work to is 0.2 or 20. This is all in metric. However, once the gasket's bolted down, and I normally don't use any sealant with these, I use just grease. I do know some people put sealant on them, but they do also collapse. Now, a gasket, once it's torqued up, drops down to, what would you think? 0.1, 0.2, 0.001? They actually drop to about 0.16. So this is a gasket off this gearbox. This is now down to 1.4 on that side, so we'll just do a couple of points. Double check my vernier, see if it's on 0. 0.15. 0.16. So that varies between 0.14 to 1.6. I normally work on a standard measurement that these will crush down to is about 0.16. So it might start out at 0.2, but once it's torqued up, it'll go down. So we need to think of that when we do our total calculation, that if we have a clearance of, and the clearance that we need to achieve is 0.2 to 0.3 of a mil. So it's pretty tight clearances. It shouldn't be looser than that, and certainly any tighter than that they will bind and get stiff when they get hot. Too loose and they get difficult to change gears with it because they do expand out a little bit. So we'll do a few calculations. So I'll come back to you when we've done all the calculations. Now that we've made our measurements in here, down there, and add it all together, including the gasket, we've come up with a figure of 156.95 approximately. So we now need to measure what we've got here and see if we can figure out if we've got to clear the difference between here and what that total measurement is should be somewhere between 0.2 and 0.3 of a mil. So we'll do a quick measurement across here just to see what. And we've got 156.92. So that clearance on there, 156.92, and we had a 156.95. So we've got an issue where we need to reduce the clearance down on one of these shims on here. So we can't touch the one on the bottom because we said that's got to be a thick one, about 1 mil. So the only one we can do is adjust this one either by putting smaller ones in, and they go 0.65, 0.75, 0.8, 0.9, 1, 1.2, there's about 5. So based on whatever we've got here, we need to measure this one. So that's 9.3, and we have a clearance of 9.392. So we've got to be able to reduce this one down a little bit. So this one's 0.91. So we probably need to go back down to 0.7 or something like that. That one's a little bit smaller. So if we pop him on and measure across there. Again, so 156.72. So from 7.2 to 9.2, 7.2, 8.2, 9.2, that's 20.2, and there was a variation in the measurement, so I had a calculation of 156.92 to 9.3 going down, including the gasket, and that now measures 156.72, so, and we're looking for a clearance of between 0.2 to 0.3. So that puts now this guy pretty much in the smack in the range. So towards the top end of the range is probably nicer than too tight, but you certainly wouldn't want to go 0.4 or 0.5, too much movement backwards and forwards. Makes the gearbox quite difficult to get in and out of gear from time to time. And that is how we adjust one of these gearboxes. Thank goodness they don't do this anymore. So the 6-speed boxes are much similar to what the small block gearboxes are, where everything is pre-machined. It's all set and there's almost zero adjustment to do. There's a couple of things you have to do in a 6-speed box, but nothing like this. So these days have gone with having to do all these adjustments. So I hope everybody gets something out of this and they understand how to adjust these gearboxes. And the critical one is this guy here. This 1 mil to 0.95 is the first one that goes in. And when you pull them out brand new, you should always see that clearance as being the thickest one. It was explained to me that should always be the biggest one, and the numbers we're looking at is somewhere about 0.95 to 1 mil. Can be a fraction over, but it's about, if you work on 0.1 minus 0.05 to maybe 0.02, absolute max, you'd be in the right position to have that, and then all the adjustment is done on this end. Can't do it any other way. With that, I hope you feel that you're a little more confident in having a go at your own transmissions. If not, I can be contacted from time to time, but sometimes I'm a little bit slow in answering emails. Us old people don't answer emails very well. With that, have a good day, guys. Lucky you're dealing with seniors here, because we've just had a senior moment, and I've suddenly remembered There's one other thing that I probably should remember where people get caught out, and it actually causes lots of expensive repairs in gearboxes. The good old Speedo drive. We'll just get this apart for a moment. So, Speedo drive in these 5-speed gearboxes, most people know, it goes in here. Sits in there. It's got some supposedly washers on either side and that screws on the top. One of the things that goes wrong with us people who repair them, or try to, is there are 2 shims that go on either side of the Speedo drive. One goes there and one goes there. Critical. They're not super hard, but they actually are hardened. What happens is, this is the one on the bottom. People pull the Speedo drive out and don't know it's in there. So when you pull it out, and if we look down on this side, we might be able to see it just in there. If I lift that up, it will drop out. Look where it's sitting, right next to the bearing. In the real world, that will stay in there and get wound, eventually wound through that bearing. Hence, we now have a catastrophic gearbox failure in most cases. All the metal goes through this, goes right through the box, and an expensive repair. So be very careful when you pull the Speedo drive out. If you do not have that hardened washer, you need to find it. It must be in there somewhere, and it means pulling the gearbox out to fix it. So the way that I get them in and out myself is, if you're careful in situ, there's normally oil on there, so you can pull these in and out in place. If you just lift it up gently and twisting it, normally the washer will stay behind and won't fall out. It is actually locked in place to some extent. I always check to see if it's down there, and then what I will normally do is with a little magnet, we'll put down there and make sure it's in there. So you put a little tiny magnet in, put it down, picks up the steel washer, you can lift it out, clean it all off, check it, see if it's A-OK. Then to put it back in, all you need is something like this little scriber. You slide your washer on top, put that down into the middle of the hole, and as you can see where it's all sitting, maybe, I don't know if you guys can see that, it's sitting in there and won't move. Now if I don't shake the gearbox around too much, it'll be fine. So I just gently insert this guy down into here, shift my hand, and you don't wriggle too much, in place. There was one on the top, then you put this in and you won't have a problem. Do not put copper washers underneath this. I've seen people, because they sometimes will leak a little oil through here, a little bit of Loctite or thread tape on there. If you put a washer under there, that clearance increases. So all of a sudden this guy is now jumping up and down as it works. Okay, it won't come out, but it actually causes excessive wear. So just be careful of that one. It can save you a lot of expensive repairs.
Well, I hope you enjoyed that. I know I certainly did. Now I hope to invite Bill back in the future to cover a few more topics regarding Moto Guzzis. But that's it for this particular video, so I'll see you next time.